then no worries. And how easy is it to swap over?
Easy. I'll help you.
Yeah, okay,
I'll help
right.
you. Thank you.
Nice. Right, guys, let's kick off. So, my name's Toby Richardson, and I'm from Curiosity Software Ireland. And yeah, first of all, we're going to do a few introductions. Then I'm going to tell you a bit more about the company. Then I'm going to pass over to my colleague George, who's going to show you some real-life scenarios of how we use our software and how we help people. And then it's going to be back over to me, and I'm going to tell you a bit of a comparison between small companies and large companies, as I've worked at both. And then we're going to hand over to James, who's going to give us a bit more information about any potential internships or how you can get involved. So that's what I've just covered. Perfect. Okay, cool. So, James, am I all right to talk about you?
Yeah, sure.
Okay. So I promise I'll just say nice stuff. So, James is he's got a BSc, Masters, and a PhD in computer sciences. He even did his Masters with Bob here, and it was Bob, I believe, who introduced James to one of the other C-suite executives, who's a guy called Hugh Price, who I know, who introduced me to the company. And he also did an internship with a company called Grid Tools, which Bob sponsored. So I also did an internship with Grid Tools, and you'll find out a bit more as we talk about the company, about our rich history in the test data space and the previous iterations of the company and our history of how we've grown. And then also, so yeah, he was employed by Grid Tools for 4 years. And then CA Technologies bought Grid Tools. And then, so that was a big corporation. James was working there. Then CA Technologies, so James moved on, thought him and Hugh could do something much better. And they founded Curiosity Software, which is the current company that we work for today. Do you want to quickly do yourself?
Yeah, so hi everyone, my name's George Blundell. So I was here a couple of years ago, did 3 years at NTU, then did my Masters here at University of Nottingham. I've been working with James and Toby and the team for the past sort of 4 or 5 years, and yeah, mainly working on customer stuff. So as Toby said, I'll be giving sort of a bit of an introduction into what we do, and some real life scenarios as well.
Cool. So my name's Toby Richardson. I did a summer internship with Grid Tools in 2013, and that's how I got really exposed to this industry. I then went to Leeds University, and I did a Bachelor of Science and a integrated Masters in microbiology, which is quite a topical subject at the moment. I then decided I didn't really want to go into an industry of research, so I actually joined the data and analytic departments at PricewaterhouseCoopers. I didn't know who that was. When I was at university, they're one of the big 4 firms, one of the largest employers in the world. They are mainly an audit company. Audit is something you guys probably aren't interested in and is quite boring, but they also had a data and analytics department, and that was very much consulting and going to other clients and delivering my data and analytics capabilities. I then saw the light and joined Curiosity Software at 2020, about 2 years ago. And currently, I'm very much on the consultancy side, so I'm helping customers solve their problems with our software. And I specialize a lot in relational databases, so things like SQL Server, etc. So Curiosity Software, who are we? So as you can see, we've got a few photos of us having a lot of fun up there. The vast majority of us knew each other beforehand in certain roles, whether that was at Grid Tools, whether that's at CA Technologies. In my case, I actually knew Hugh Price and a few of the guys from my school days. Hugh was actually my head coach for rugby, so I've known him for a very long time. It's quite nice to actually go to a company and work with people you've known since you were about 5 or 6 years old. We've got a very rich history in the test data space. So as I mentioned, Hugh beforehand and people like James, they've been in this industry for about 35 years or so. They were actually, C-suite executives at this company have collectively founded 5 very successful companies, which have been sold to bigger companies such as CA Technologies, and that software today is still in use. We're currently 6 years old, and we have 35 employees. So James was one of the founders, so he would have been maybe 1, 2, or 3. I'm not quite sure which one. I don't think it matters. George was employee 9, and I was employee 15. So that just shows the rapid growth that the company's had in our recent history. So what technology do we use? So our front end is a web-based platform called Test Modeler. That is the link up there for it. And if you just do a quick Google search, Test Modeler, you can see our software. We have a multi-tiered architecture. So we allow people to get at the data underneath that our application uses and to use our application in many different ways. We've got APIs that you can kick off any sort of functions from. We've got APIs that BI teams are able to take the data from the underlying database and ingest into their dashboards and work out their KPIs from that. We also have a Postgres database underneath which stores all of our data. And we've also got lots of different agents. So we can take one job, and we use this a lot for when we're generating billions and billions of rows of data, and send them off to different agents so they can work on the same job simultaneously. The main languages that our software is made of, so we've got Java, Angular, and C#. The vast majority of Test Modeler and the web front end is Java with a bit of Angular. And then we also have a sister product called VIP, and you can see the logo in the bottom left hand of the slide, and that's where most of the C# code is. So for source control, we use GitHub, and you can find, we actually have a question answer discussion thing on our GitHub repository, so you can ask questions and somebody like myself or George will answer them and help you use our software. And then for our containers, we primarily use Docker, and that could be on a Linux or Windows system. Cloud platform, we majority for our internal business use AWS, but we also use a bit of GCP for some security features, and we can work with Azure if need be. And then in terms of developing software, generally our developers will go and find really cool libraries that people have developed and have made use for public use, sometimes found on GitHub or Stack Overflow or something along those lines, and then we incorporate that into our software and deliver and interpret those libraries and get them to software so we can solve our clients' problems. So is this over to you?
That's fine, I'll hold it. Okay, so I'm going to talk a little bit about what we actually do. So we are very much in the software testing and development space. So there's kind of a lot of pretty standard challenges that you see with software development. This is quite a cool slide. It sort of goes through the journey of, okay, well, how the customer explained what they want versus what they actually wanted and how they actually got the product. Basically, this is talking about miscommunication and how, it's kind of like a game of Chinese whispers in some companies. The customer says one thing, the salesman says another thing, the developer says another thing, and then you end up with a roller coaster, for example. Now, one thing that can tend to cause that are the software requirements. So very often these are kind of walls of text where you basically got a JIRA ticket or something else where, it's 5 paragraphs long, no one really understands what it means, which will lead to some of those ambiguities. You can kind of think of it as creating a house. So, if you're building a house, the homeowner will come in and create a rough sketch of what they want. Then the architect will come in and say, well, no, we don't want this, we want that instead. And eventually you build up kind of a more representative picture of, what you actually want to receive. So that's kind of what we do for software development. Apply those same principles to the life cycle and create essentially a graphical model of what the software should do and based off of the requirements that we've received. So, having a model, as if you're working on a house, being able to refer to a visual diagram is much better for communication, and you can actually see what you're going to be building. Then, absolute key there. Once we've created your models, they become kind of like a living documentation of your system, and as I'll show you, we can create automated tests, not just manual test cases, but automation code as well, that goes away and tests 100% of your requirement. So what actually is software testing? So typically, it's as simple as, does the software work as expected, and does the software actually meet the requirements? There's kind of lots of different types of testing depending on what you're doing. The most basic will be, I guess you call it manual testing or functional testing, where you're literally going through, clicking through your application, making sure all the buttons work, and you can enter data that you need. On the other hand, you might have stuff like performance testing, where you're pushing through, as Toby mentioned, 1 billion rows of data into my API to make sure that it can actually handle it. It's a really, really wide-ranging sort of topic. So with the platform that we've got, we can kind of do all of those things. So let me show you a quick example that we will sort of be writing some tests against. So okay. So pretty bog standard, right? I mean, this is kind of the classic example. If I'm ever showing a demo to a customer, this is the kind of example we go for. Super simple, a login page, email, password, you've got some emails, got some valid passwords in there. Now, there's kind of a few ways that we can actually test this. So I'll cover sort of three main ways. We go to this one, we'll create some manual test cases first. Then we'll create some automated test cases, and then we'll create some modeled test cases. So if we consider how do we create a manual test case on this page, typically what people will do is they'll come over to a planning software, typically be something like Jira or a test management software, and they will literally come in, create a table, and put all of these steps on the table. Navigate to website, select button, enter valid email, etc., etc., etc. Now that's fine. It's a test. It works. It tests that we can actually use this application. But think of the process of doing that. It's boring, slow. If you've got 100 screens that you want to test, you've got to do this hundreds and hundreds and hundreds of times. And then actually once you've written that test, then you've actually got to go and do all of those actions. So go in, enter your valid email or your valid password, and do all that stuff manually. Now, the other way of doing it is kind of the similar kind of process, but actually creating some code and some automation for it. So what I've done is I've just gone away and created some automation code, which essentially automates that scenario that we talked about. So if you see here, we have a test case. So this is Java Selenium. It's one of our kind of standard technologies that we really use with, to be honest, most of our customers will use this kind of framework. Basically what this is doing is it's, okay, first I'm going to go to a URL, then I'm going to enter an email. That little enter email function has a parameter called, email, and then we're basically pushing through the valid data through into there. Same thing for password, same thing for sign-in. And essentially now that is an automated version of that, the test case that we created. So we can come in and run this. That will go away and spin up a Chrome driver. And if you give it a second, we will see it go away and actually run that test for you live. So it opens Chrome, could be Firefox, could be anything, and it fails. Brilliant. Oh dear. That's not good, is it? Let's try the other one. That's impressive. Ah, it's because I'm not connected to the internet. That'll be why. What's the best way, Bob, to connect to the internet? I might be able to sign in. Oh, God. Okay, you'll just have to believe me that that basically goes away and loads the web page and then actually enters that data. Now, that's fine, but typically the process is still the same. You know, I'm still going in and writing all of that code manually. You know, it's a bit more entertaining, it's a bit funner. Typically it's going to be faster, right? Because then I can actually just press play and that goes away and runs those tests for me. However, it's more difficult than manual testing. Obviously, you're writing code. You need people to actually write that code. It's obviously more expensive because the people who can actually do that are going to be typically more expensive to hire than someone else, which is where we kind of come in. So model-based testing is kind of a nice in-between where we can actually come through and create models of the system and generate those tests automatically from the model. So if we take a look, so this is one of our, it's kind of one of our models here, and this represents that login page that I was talking about. So at the beginning here, what we've got are essentially automation code snippets that are basically calling different functions for us. So this one goes to our page, then we're considering, entering emails. This kind of relates back to, these sort of code snippets in here. So where we're entering passwords and things like that. Now, once we've got this, we can actually go in and generate those tests for you automatically. So as we've come through, I've gone actually and created 2 paths here. And each one of these paths takes a slightly different route through the application. And we can also then come in and generate. I think typically what a lot of organizations spend their time doing is maintaining these automation frameworks. So like, if you guys end up going into testing or a similar industry, you've got, in this instance, a Selenium framework. And, people are spending hours and hours and hours messing around, essentially just maintaining all of these pages. So like, for example, if I show you this, so this is that the Java class file for the customer login page. And basically how this is structured is we've got sort of declarations. Okay, well, this is my email element. We use typically XPaths. So if you've built like a HTML application, essentially you can pick out different elements of your screen using things like XPaths, selectors, IDs, things like that. Once we've got that element declared, down here what we're doing is, let's go and say, okay, for this enter email from line 92 down, first of all, we're actually just going to go get that web element. Then basically it's as simple as, okay, now I'm going to send some keys to that element. And as part of that, we've also declared some kind of parameter in here, our email parameter, so that when we're coming in and creating that test case, we have a parameter that we can fill in. So that's our invalid in this scenario, or if it's valid, we've got our valid email. So that's kind of a bit of a rough approach as to how we do things. Typically, I think it's quite a new way of working still, model-based testing as a whole, but and software development as well. So this is a bit of a eyesore at the beginning of this slide, but let me break it down a little bit for you. So essentially, Test Modeler allows you to create a reactive model of your system. Now that model can be used for testing, as we've just seen. However, it could be used by developers as well, because it kind of paints like a visual picture for you, which you can then use to write code and build the software. Now, there's lots of inputs, so things like existing test cases, BPMN diagrams, which kind of are that map of behavior that you might want to import. We also work with tools, as Toby mentioned, like GitHub, where we can basically go ahead and import code from GitHub and build models from that code. That's, to be fair, what quite a lot of our customers are doing. They are making a call to that repository and then pulling in the code that they need to then build automation scripts and tests from. Now, I mentioned that tool Jira. We integrate with quite a few tools. Most customers and most people we work with use Jira. So I suspect you will all end up working with Jira at some point. And it's a pretty cool tool. It's all about sort of managing software development. And as part of that, they have sort of test plugins as well. So if you want to get ahead of the curve, I'd say learn a bit of Jira. Really, really useful. Now, obviously, to test, you also need test data. So, that's things like those valid passwords or valid emails that we talked about. And what we can do is we'll basically go and grab that data from somewhere else. So whether it's like a SQL Server database, can be something simple like a spreadsheet. To be honest, most testers will still be using Excel spreadsheets and just uploading data from there. But there are, there's so many databases out there that we've seen and people work with. So it's all about just finding that right database for you, depending if you want relational databases or just, spreadsheets and lists of data. Now, what we've also looked at is also the sort of test automation piece. So in that example, we were creating Java code using Selenium to actually automate the application. However, there are hundreds of different, not hundreds, but absolutely loads of different types of automation. Depending if you want to automate a mobile application, you might use something like Appium. Whether you want to do, mainframe testing or sort of desktop testing, you use lots of different tools. But essentially, with Test Modeler, it's kind of an amalgamation of them all. So you can create any code that you want. So any code that you guys are working with now, we can import that into Test Modeler, and you can create loads and loads of automation scripts from that. Okay, so hopefully that gives a decent overview of what we do. If you do go into the testing industry, I would assume the problems that I've talked about there you will probably see. Or even if you don't go into testing and go into development, then most of the same problems will still be there. Okay, so I'm going to hand back to Toby, and he's going to talk a little bit about what it's like between sort of working for a large company versus a small company like Curiosity.
Perfect. So just a little recap. As I mentioned earlier, I started my professional career out of uni by joining the Data Analytics graduate scheme at PwC. So I guess there's a quick question of what does that mean to you guys? So I joined the graduate scheme in 2016. Yeah, there we go. Now you can see that. Yes, I joined the graduate scheme in 2016. At that point, my experience with computers wasn't that great, if I'm honest. I'd done your IT general basic skills at school, which meant they showed me an Excel sheet and showed me how to do a few formulas. I played around with Linux as a kid because I thought it was cool and I wanted to get my laptop to work, which was getting so old that it couldn't run Windows. But apart from that, I didn't really have any sort of computer skills. So PwC was a really good opportunity for me to almost make a change in industry from my lab base doing virological, so like growing viruses and testing what kind of proteins they're expressing, into something which is a bit more industry specific in the world of data and analytics. So as an associate for the first 2 years of the graduate scheme, my role was very much around building my technical skills. So we used to do some analysis on the data we used to get from companies around their financial data, and we would support our audit teams using that analysis, and we would be looking for things like, okay, can we see if there's any signs that we're missing any data? We're looking to do some basic aggregations to tell them, like, the total amount of transactions that are coming through, the numbers of rows, the total amount of money, and then also we would be helping our audit colleagues and their accountants, so things like trying to work out important metrics for the business, stuff like cost of sales. And then also, alongside that, I was developing my skills in T-SQL. So I'm certified for SQL 2016 for both databases and writing Transact SQL. And I was also developing my skills using data visualization tools such as ClickSense and Power BI. So one of the projects that I was on, I was working with a well-known Yorkshire pudding producer, and we were helping them with their trade promotion analytics. So what that means is we were trying to help them predict how many Yorkshire puddings or toad in the hole or what kind of products in certain months of the time. And then we were also helping them with their analysis of, okay, does buy one, get one free actually save them or make any money for them? We actually found from that for this particular customer, so a particular client, buy one, get one free offers were not financially beneficial for them, and they were actually losing money from that. And we would recommend that actually with the increase, something like 2 for free is much more beneficial for you guys as a company. Then as a senior associate, I was developing my technical skills to be more mature, and I would be taking on some of the hard technical tasks in a project. So for instance, the last project I was doing at PwC was I was helping build a internal, data transformation process, which a client would be able to upload their data to a SFTP server, and would have the necessary cybersecurity details to allow highly sensitive data to be uploaded to that and be GDPR compliant. Then that would be ingested into our Azure system. So that would be, I don't know if you guys are familiar with Azure, but that would be using Azure Data Pipelines, which would work as an orchestration tool, kind of similar to SSIS, just a bit more modern. And then that would be kicking off the data into a SQL database, which would have certain stored procedures, which would do the transformation, spit out the results, and then give it back to the customer. The benefit for the client for that was that instead of having to manually do it with PwC each time, which could be like 25 to 30K, they would just pay like a monthly subscription fee of about £5,000 and be able to do that result as many times as they would like to make sure that they were compliant with specific FCA industry standards. Another thing I was doing whilst I was a senior associate is I would be taking more of a role of engaging with the clients and also coaching up the associates to help them upskill and become better. What I would say about the PwC grad scheme, it is a great induction to the working world. There's a lot of structure there. You get a lot of regular feedback. So at the end of every project, and a project could be maybe 1 month to 4 months, you would have feedback with your managers and senior managers and also your peers about how to get better, ways you could improve, and that would help you set targets, set goals, and and help you to achieve them. You also got a huge variety of different things. So in my experience, I was also helping the identity access management team with certain analysis of different user accounts, saying, okay, you've got multiple different systems across a company. Say and you want to know, okay, is my username the same if I log in? If you've ever used something with single sign-on, which means you just have to log into your laptop, then it will log into all your systems. There's computer programs underneath that, which are actually helping you sign on and making sure it's nice and secure. So I was helping the team with that. And I was also, as I mentioned, helping develop data warehouses, helping develop Azure systems. So a huge variety of different projects I was doing at PwC. But it did mean it was hard to specialize. And you have to get quite high up in PwC really to be able to specialize as much as possible. So that's kind of what I was doing at PwC. At Curiosity, So how did I get involved with Curiosity? So I knew Hugh Price from my school days. I'd done an internship with him at Grid Tools, and I saw some of the exciting work that he was actually posting on LinkedIn. I know that sometimes that's a bit of a cliche, but generally did get me this, it did start out the connection. So I reached out to Hugh and I was like, hey, some of the stuff you're doing is really, really cool. I build a lot of ETL pipelines, but nobody has any idea really how to test them. It looks like your technology, I think it was actually Hugh's video on testing ETL pipelines, like, cool, is there a way that the industry could use this? And one thing led to another, we were talking, etc., had a few meetings, and then I was suddenly talking to him about a job offer and whether I'd like to come work for him, which I jumped at. It was a great opportunity. At Curiosity, I still focus mainly on delivering for our clients. So it's very much a lot of problem solving, a lot of listening to clients and understanding their problems and giving them solutions. But I actually now participate in Curiosity a lot more about the day-to-day running of the business. So I might be involved with the marketing team. I might be involved with a bit of documentation. And also at Curiosity, because it's a much smaller team, people like James will actually listen to me if I want to, and my opinions about the direction of the company. Whereas at a place like PwC, there's absolutely no chance of that at all unless you're very, very high up. In terms of the atmosphere, it's not quite as structured as PwC. There's a really good, relaxed atmosphere. It feels like, well, quite a lot of them are my school friends, but that has extended to the colleagues I didn't know before Curiosity. And yeah, there's something very unique and special about working at a small startup with a very lateral organisation structure and also be able to work for your friends. And it does give a really nice work-life balance. So if we talk about what the difference is of working at a small compared to a large company. So the PwC has a really, really good graduate scheme, and it gives you lots of skills to prepare yourself for the working world. So it's not, if you remember the picture that George showed you earlier, there's a lot of PwC about working out what the root cause analysis is and actually working out what the client wants. As you saw from the picture, the client may actually need a tyre around it, whereas what got built for them, I think it's a seat which is tied multiple times around the tree. If you can improve that communication, it means that you can deliver something much more of much greater value to the client. It's also about listening to the client as well. And then there's one project at PwC which we were getting quite wrong because we wanted to use all the new greatest technology with Azure, like Azure Cosmos DB, when actually what the client needed and what was more valuable to them was really just the ability to store their data and have some very simple data analysis in the cloud. And as soon as we changed trajectory on that project, because we were listening to the client saw much greater value and we got much better feedback and they got much better value for the money they were spending with us. And at PwC, because it's a lot more structured, I would every single month be getting feedback, constructive criticism, etc., on how to get better. But what that does mean is there is an added bit of stress. There's quite a lot of burnout at a place like PwC. People are working much harder hours and sometimes a lot less efficiently, especially because PwC will typically charge by the hour. It's how they make their money. So there is a balance. What I have found since working at Curiosity, my work-life balance is a lot better, a lot more flexible at Curiosity, and so I've really enjoyed it. One difference is the hierarchy. So we've got a very flat leadership structure, Curiosity, which has its benefits in a lot of ways. So I can make a lot more, I have a lot more responsibility, I can make a lot more impactful decisions. It does mean, however, if something goes wrong, I don't have anywhere near as much air cover. So for instance, PwC, if something goes wrong, I've got my manager, I can try and push the problem to then senior manager, director, then several levels of partners who can solve the problem. Whereas at Curiosity, there might only be one or two, maybe one level above, if that I can go to try and get that air coverage. But everyone at Curiosity is still incredibly supportive and help you can solve the problems. That being said, I now have more responsibility at Curiosity, which I personally enjoy, and therefore I can see the impact of my decisions. And is there anything else? Yeah, I would probably also say that the working culture at Curiosity is more flexible. So contractually wise, I think I can do my work any time between 6 a.m. if I really wanted to and 10 p.m., which is a bit more likely. whereas PwC was a lot more regulated in that you had to be working pretty much from 8:30 to 6 or something along those lines. So yeah, so I think you can really capture that as a difference is structure versus freedom. So if I can, so if we go on to industry tips, is that going to come on? Yeah, so don't stress. Yeah, so and this isn't just for the IT industry. I was talking to my friend who's a HR senior manager, and she would agree with this as well. It's not, when you get out of university, don't be scared of trying a few different things, especially when you're a few years into your chosen interest. It's a lot easier to try loads of different things. It's very easy to transfer. Whereas as soon as you start getting quite senior and quite specialized, if you do want to switch, sometimes employees are quite wary of that because they don't think you'll stick around, or you'll have to take a salary jump down to try and start at a more junior position. And if you're okay with that, that's fine, but it's not, especially with mortgages, etc., it can be sometimes a financially difficult decision to make. So don't worry about, you can't go too far wrong at this point. And the more experience you get with different things, the more likely you are to find that one thing that you really, truly enjoy. So kind of what I mentioned at my time at PwC, having regular goals and targets is something really good to keep you on track and actually so you can measure your success. I remember back to my uni days actually, at the end of my exams in second year, so my Christmas ones, thankfully they weren't worth that much, but I did really badly in my exams. So I was like, okay, I probably need to stop drinking and partying so much and actually spend a lot more time in the library. And I changed my grades from about 55% to about 75%. Just from spending more time in the library, and that's because I set myself the goal of, okay, I'm going to be in the library 3 days at 5 after uni. I'm going to prepare all my notes before my lectures, and that's all about setting yourself goals, and then you can see your tangible results become good to them. And I would say that's a really good tip and habit to get into now, and it will serve you a lot later in life. Keep learning, the world is changing, and I don't think that's any more true in IT than it is today. Sometimes I'll talk to my colleagues who are still at PwC, and some of the stuff that I used to do for them is probably outdated now, especially some of the stuff I learned in the first few years. That was only, 2016, 2017? So really not that long ago that things are already becoming outdated. And especially in somewhere like IT, we come across old software all the time, and it's striking how much of a competitive disadvantage that gives you. And you also find that people, as they get older, are less a lot of people less enjoy learning. So if you still keep that hunger to learn, that will give you a real good competitive advantage going forward. And it's also fun, what I personally think anyway. Yeah, so you'll see this a lot in companies that they're trying to build a culture where it's okay to fail, it's okay to test things, because you can, if you're too afraid of failure, you can spend months and years trying to work out all these sort of theoretical problems. But I imagine you guys have experienced yourself when you actually try and build something. There's only so much you can predict, and really you'll be able to get to your goals and find your route to success a lot faster if you start doing things and failing. I think a good key corporate phrase, which I've actually heard and I actually quite like, is failing fast. And the idea is that you get to your failures as quick as possible, therefore you can manage them and progress from your learnings. And then, follow your passion. So, one of the reasons why I came to Curiosity is I was following my passion of, okay, ETL pipelines, great building them, really interesting, great gaining a lot of traction in the world. People are really, really excited about data and analytics. But one thing that has not been very prominent is actually testing them and making sure that those figures you're producing are right. Why is that important? So one dashboard I built for this client was about risk and opportunities. And so we're telling them about, decisions which will be where they invest millions and millions of pounds. So you need to get these decisions as right as possible. a dashboard which we hadn't built but they were using from one of our competitors actually had a mistake in it, which meant that they spent about £2 million on the wrong product. Because that dashboard wasn't tested, because they didn't test that ETL flow, they put £2 million into the wrong product and then had to do a flash sale of that product to try and recoup some of the profits. So yeah, but if you find something you're passionate about and something that you care about, it will give you that drive to succeed in it. And one thing I forgot to add onto there, I would really, if you get the chance, I would get involved in clubs, activities, things which help you develop your soft skills and talking to people, and that way you can really help you. Going back to the picture that George showed earlier, it's about that step of actually understanding what the problem is and that root cause analysis, which I think is so important. And you're great. And at the end of the day, it doesn't matter how good your technical skills are if you build the wrong thing. So yeah, I would definitely try and get as much extracurricular activities as you can to build those soft skills. I think I'm handing over to James.
Yeah, is that working? Good. Yeah, just a bit of marketing, I guess. So I think you guys are in an absolutely fantastic position. If you look at the industry at the moment, especially in technology, it is so underserved. So just by doing computer science, learning technology, you guys are going to be pretty in demand when you go out there in industry and actually look for a job. So well done. Bit of marketing from our side. We are looking for internships or interns to come and join us. We're looking for graduates. We're looking for people who are kind of hungry to get involved in industry. I think what sets us apart from other companies is, firstly, we like to have quite a lot of fun. So we're all going on a big ski trip next month. I think there's something like 22 people coming. So that's one thing. The other thing is that, kind of like what Toby was saying, you end up in the pointy end. You're kind of coming out, you're getting a lot of experience very quickly. You're working with big companies, you're working with small companies, you're seeing lots of problems, and you're kind of growing really, really quickly. Whereas I think when you work in a big company, you're really going out and you're very focused on perhaps one small area, or you're working specifically with one client. So yeah, if you come and join us, you can go out, you can learn lots very quickly, and also have a bit of fun while you're there. So yeah, just get in touch with any of us. My name's James, we've got Toby, and we've got George. If you'd like to talk more, just get in touch, and yeah, we can take things from there. So yeah, thanks. Thanks a lot, guys, for talking.
Any questions for industry experts? How many?
One question. When does testing become too long? When do you have to wait back? Because there is obviously a point where it's like...
Yeah, it's a good question. So I think it kind of all comes back to value. What is the value of doing something? Why are we doing something? So you're absolutely right. People could test way too much. If you think about, I guess it comes down to two things. You could have something in a system that's been there for a very long time, and in that case, it's probably already pretty established. There's not that much point in testing something unless it's changing. The second thing is that you could have a piece of functionality which actually not a lot of users are going to be using. So maybe like 0.01% of all users who hit a website are going to go through this specific journey in an application, right? So I think it's always, what is the value of testing this, and that's kind of what it comes down to, if that makes sense.
Any other questions for industry guests? How many employees are at PwC? Do you remember?
A lot. Yeah, I'm just trying to think.
Multinational.
Yes, yeah, multinational.
Probably thousands, tens of thousands.
Tens of thousands. In the data analytics department, I think there was about 500, 600. There was about 50 people in Leeds, 50 in Manchester. So yeah, pretty sizable. I think it's one of the highest grossing companies in the world. Billions.
I guess this is kind of a problem which not sure if you can really solve, but how do you ensure that your tests are valid? Like, do you test the tests, or how does that work?
So I think a lot of it comes down to kind of domain expertise. So one of the things that often happens is someone will go away, like a tester, a manual tester, whoever is kind of owning quality and owning writing those test cases. They will go away and they will come up with their own interpretation of this is how we should test something, right? And then everyone else in that kind of testing area or every other stakeholder in the project doesn't really get visibility into how something is being tested. If you think about the purpose of testing, it's actually giving people confidence in what we're about to release or what we're about to ship. Like if I'm going to release a product, I want to know that my customers will be able to use this and actually, it will work properly, right? So if you think about that, we're kind of coming back and we're saying, you need to go in and figure out that that's working. You need to have visibility into what's being tested, right? So our whole approach is built around visualization. People can come into the test cases, they can see a visual model, a visual representation, and see exactly how this part of the system is being tested. So it's more about giving people confidence. Sometimes we will find that people will look at the model that George was showing, they will look at that visual image and they will say, this is not how we should be testing this. We're not testing it enough, we're not testing these different deviations, or we're testing it too much. So I think it's more just giving transparency, letting people know how we're testing something, rather than saying we need to test the test. You're just saying this is how we're testing it, and people can say that's enough, or it's not enough, if that makes sense. Yeah.
Other questions? How do you guys feel about open source software? Do you have something like open source testing?
Mm-hmm.
Where somebody from the outside can see the test data or the set of tests that you run or something like that? Or is everything proprietary?
So we use a lot of open, so I guess there's two answers to this. Internally, we draw a lot from open source technology. I think if you look at what's out there at the moment, you just Google something, you find like 1 million libraries that are already out there. So we extensively use libraries ourselves internally. And the benefit of that is you can build stuff so quickly. We had a company before, Grid Tools. We probably spent, 5 or 6 years developing a piece of software. We started Curiosity Software. Within about 3 to 6 months, we had equivalent software that did the same functionality, just because there were so many open source libraries we could pull down to kind of bootstrap and help us get started much faster. I think the other end of that is, do we produce open source software, or what is in the testing industry? Most of the kind of software that people use to test, especially in automation, is open source libraries. So what George was showing is something called Selenium, which is like a way to connect into Google Chrome or Firefox or Internet Explorer and automate clicking on buttons, entering text, etc. So we leverage those libraries when we do testing, and we generate into open source frameworks. We've also released a bunch of open source frameworks ourselves to help people test, like web apps, APIs, desktop applications, etc. So we do that, but mostly it is so that we can help people use our product, if that makes sense. So it's a little bit selfish, but